Muy buenos días.
Well, good afternoon. Okay, third try. First of all, I would like to introduce myself. My name is Daniel Guasc, and I'm member of the Scientific Committee of the Conference and Director of the Accessibility Chair of the Polytechnic University of Catalonia, and it is a great pleasure for me to introduce Dr. Alain Pruski. He held a chair at the Metz University. He's an expert in the application of technologies for the disabled. He's co-founder and member of a group of institutions and companies that work at national level in France to adapt technology to disabled people, and also publisher of magazines and books always related to disability. He's going to talk about a topic which he is very well acquainted with, robotics and virtual reality. He's going to speak for about 50 minutes. He's going to give this opening keynote speech, and after his presentation, we will open a Q&A session so that you can ask for any clarification that you might need. Without further ado, Dr. Pruski, you have the floor.
Thank you. I'm sorry, I don't understand anything. I don't know what you have said. I'm speaking only English, but bad English. I hope I'll be understandable. First of all, I want to thank the conference organizer to invite me for this conference. I'm very honored and proud to be here with you today. My talk today concerns robotic assistance for disabled people. I stand up to activate my PowerPoint. I'm coming from France, from northeast of France, about 300 kilometers on the east of Paris. You don't see my PowerPoint. Technical problem. Yes, I have a map to show you from where I'm coming. Yes, you can see. On the left, you have the France, the map of France, and in red, there is a region called Lorraine, and I'm coming from this region. A town called Metz is the main town of this region. In this town, there is a university, and the university called Paul Verlaine, and I'm working in a laboratory. There is a LASK laboratory. This is Translate Automatic Control and Behavior Science Laboratory. We are 16 researchers and about the same number of PhD students. And the topic of this laboratory is focused on assistive technology. We develop 4 types of research, 4 points: mobility, accessibility, cognitive stimulation, and augmentative and alternative communication. And today my talk focused on robotics. Robotics used in the field of assistive technology. If we take a look on what we can do with robotics for people with disability, we have 3 kinds of application: mobility, manipulation, and social function. And today I want to focus my talk only on the 2 first points, mobility and manipulation, and we are not working on social function. You can see for social function a seal here which have an affective function for people, for aged people, for example. First, mobility. I have worked on mobility field for 20 years ago, till 20 years, beginning 20 years ago, and according to the disability, we can see that the people have difficulty to drive the wheelchair because too weak residual capabilities or too much spasticity, important tiredness, or different cognitive troubles. And in most cases, only an on-off sensor can be activated. And then we can see there are some problem to maneuver, to have fine maneuvers in some situations. And the solution is two-way. First, to adapt an interface, to have an interface adapted to the problem, to the capacities of the person, like a scanning device or a specific joystick. But in most of cases, it's not enough efficient. But we must transfer to the wheelchair some reasoning capabilities. And then we are in robotic field. What is very important here is a cooperation between the person, the user of the wheelchair, and the wheelchair itself. But why to cooperate? The cooperation between the man and the machine, the wheelchair, can answer to some problems. First, the robustness, the acceptability of the system, of the robotic system. This is the main problem, the acceptability. And there is a compromise between cost and performance. But how to cooperate? We must cooperate by share different tasks. But what is very important is the good sharing of the task. If you can see, the man has good perception, the man knows, can interpret the information in a closed environment, and he can have a good understanding of the global situation. And for the machine, the wheelchair, the robotic wheelchair, he can have a good mobility and have a global knowledge on the environment. And there are two aspects of cooperative mode. Either to share the supervision, the decisions of the system, either to share the execution control. And if we look how is composed wheelchair, the architecture of the wheelchair, we can find 4 parts. The seat, the motion mechanism, the different sensors, and the control of the system. Today, I want to focus only on the control, but this is our interest like researcher. There are 3 possibilities to control the wheelchair. First, to have manual motion. Second, different control referenced by sensors, like wall following, person following, doorway crossing, for example, or by using some knowledges. For example, a pass planned from one position to a goal or return backwards. Different a priori knowledge. And what is the motion problem? First, why to move? Why to move? Because the people want to meet vital necessities, to eat, for example, to participate to social life, or to increase his autonomy. And how the motion is determined. And here there are many answers, starting with different type of people. First, we have able-bodied people, the autonomous robots, the man-machine, man-wheelchair couple, or man-robot couple. And these 4 points activate not the same methodology to realize, to perform the motion. First, for the able body. The able body has a mental plane. And this mental plane is associated with visual or acoustic marks. And this plane is influenced by some information, for example, environment aspects, different constraints, dangers, or emotional aspects, for example, fear, anxiety, pleasure to go to one place. And the third point is different perspectives, future, past perspective, why we want to move, for example. And the action for the able bodied is every time the same. There are some elementary movement in order to progress in the plane. And some reflex action for avoiding danger, for example. For the autonomous robot, it's not the same. Generally, it's top-down approach. Plane, then sensing, and action. First, he compute a global plane, and the robot adapts the plane to the robot capabilities. For example, if the wheelchair is non-holonomic, then the plan must be adapted, and then the plan is executed. For the couple, man wheelchair, not an automated wheelchair, but a classical wheelchair, the men have always the responsibility of the motion. And the motion must be adapted to the wheelchair capabilities. And it's the person who adapts the plan, his plan, to the wheelchair capabilities. And here there is a very big importance of the man-machine interface. And it depends on what the person can do, what are these physical and cognitive possibilities. Every time, the output of the person is given by linear and angular velocity. It outputs this information to the wheelchair. The person has the feedback of what he sees in the environment, and he performs different time motion when the environment is cluttered with obstacles, for example. And if we take the man-robot couple here, it's different. 3 levels of assistance. First, in describing the motion, for example, in terms of instantaneous velocities, linear angular velocities, or global motion, for example, user-centered, environment-centered, or in a semantic way. For example, go to the telephone, go to the refrigerator, to the doorway, for example. Or different local motions is a set of primitives, follow a wall, avoid an obstacle, for example, or cross the doorway.